Okay, we're going to go ahead and get started this morning. Welcome to the Dairy Forage Seminar Series. My name is Dennis Hancock. I get to be the Center Director for the U.S. Dairy Forage Research Center. That's located here in Madison, just down the road on campus at UW of Madison. Our first speaker is one of our own, Dr. Mary Beth Hall, who is a research dairy scientist in our cell wall utilization and research unit. She has been with us, how many years now, Mary Beth? Since 2004. Comes from a long line of experience with on-farm research, has a history with extension at the University of Florida before coming to us. So Mary Beth is going to be talking a little bit about keeping the rumen healthy. So Mary Beth, thank you for joining us this morning.
Dennis, thank you very much. Can everybody hear me just fine? Good morning, and thank you for being here this morning. And I tell you what, just as you wander around through World Dairy Expo, what you'll find is we are probably it, by and large, for any of the folks from USDA having booths here. And we did that because USDA Agricultural Research Service, they've banned a lot of travel with the pandemic, but they thought that World Dairy Expo and speaking to our stakeholders was important enough that we should be here. So we'll try not to disappoint, and if you wanted to pass any kind words on to people for saying yes instead of no, go for it. Okay, so keeping the rumen healthy, new approach to working with fiber and rations. I want to tell you first that this is the gentleman who started it all, Dr. Peter Van Soest. He developed the analysis for neutral detergent fiber that we work with today, and he passed earlier this year. Excellent researcher, really concerned about getting things right for cows. Okay, so I tell you what, after working with cows for this many years, my perspective is that the rumen is the cow's superpower. It lets her do things that we cannot, that other livestock cannot. It makes nutrients from the things we can't use. It transforms lower quality protein into higher quality protein. It transforms fiber into energy and microbial protein that the cow can use to meet her needs. So here we have a whole variety of forages, corn grain, byproduct feeds. Here we have rumen protozoa and rumen bacteria. And when these are fermented or utilized by these microbes in the rumen, they produce gas, which we are not so fond of. It produces organic acids that provide energy to the animal and can affect the pH of the rumen. And it produces microbes, which are extraordinarily high-quality protein. That high-quality protein, as compared to what was originally in the plant, supports the animal's performance. And I tell you what, these are key, especially coming from forages and from some of the byproducts. Were it not for the cow having a rumen and the microbes converting those feeds to these nutrients, they would be of no use to us. Okay? Okay, so, I mean, for the rumen to do this kind of phenomenal job, we got to keep it healthy. It's crucial. And so, what we're looking at when we deal with what a healthy rumen provides, we use effective fiber from forages to maintain rumination, to keep the rumen healthy, a rumen mat structure within the rumen to hold feeds in place so that the microbes have time to digest them, so they don't just sluice straight on through, and which means it also affects the passage of feed. Again, holding it in place to get good use made of it. The fermentable carbohydrates that we put in, kind of the flip side of the effective fiber, are there to ferment to supply energy to grow the microbes that are a great source of protein for the cow, but they can make the rumen more acidic. It's producing acid, acetate, propionate, butyrate, are natural volatile fatty acids produced by the microbes from the fermentation of the feeds, okay? And so we have a balance between effective fiber, which gives rumination and adjusts pH in the rumen, and the fermentable carbohydrates that can create acid, or will create acid. I mean, so done right, achieving a balance here meets the cow's needs and keeps her and her rumen healthy. And quite honestly, a sick cow is not going to provide you the production you want. And over the decades, we've learned a lot about, not everything, but we've learned a lot about how to keep the rumen healthy to keep the system working. Okay, but fine. You know, I give you these broad brush ideas on how on earth we're going to keep the rumen healthy, but how on earth do we actually make that ration that's going to go in front of that cow? Because at the end of the day, all of you raise your hand if you like things that are strictly theoretical and don't have farm application. Okay, absolutely freaking not. I mean, when we're looking at the ration that we want to make to accomplish that balance for the rumen, we do have to look at the amount of forage we feed. And we're finding people feeding a lot more forage than we used to, but we've also done a lot better job of improving the quality of the forage. And if you take a look at what's in the Forage Super Bowl, you'll get an inkling on that. It's looking at the particle size of what we're feeding, because the particle size affects how much the cow is going to ruminate. Okay, and that is crucial. If it's really, really fine, you don't get that amount of rumination, you don't get the effect you'd want from the forage. Fiber, neutral detergent fiber. It is more slowly fermenting than, let's say, the starches, the sugars, and so forth. It makes up a portion of that physical form. And so we have to look at the quality of the fiber for how rapidly it digests, because the quicker it digests, the sooner it's gone and isn't going to get the cow to chew. And also this ends up diluting out the starch, which has been voted more likely to create some of the issues with ruminal acidosis, but not if properly balanced, okay? We have sugars, which are another part of the very fermentable carbohydrates along with starch that it tends to create less issues in the rumen than starch might. Again, you need proper balancing. You have your protein, your fiber, and starch digestibility. All of these factors, all of these characteristics of the feeds have to be considered when we're putting together the diet for the cow. Dennis told you that I'm a ruminant nutritionist, a dairy cattle nutritionist, right? The next thing I'm going to show you isn't just to tell you that it's not my fault, okay? I mean, but it isn't just the ration we put together, it's the ration management that matters, okay? When we're looking at ration management, how many of you have noticed that cows are kind of fond of having things on an even keel? Not lots of change that swings from one side to the other. I think even more than us, cows are creatures of habit, and the more consistent we can have the ration, the better for what they are going to be receiving to maintain their rumen health and maintain their performance. So we have a properly mixed ration so that when cows are fed, let's say, a TMR in the feed bunk, the composition doesn't change from one end of the bunk to the other. So the cows that get to one end of the bunk or the other don't get different diets, okay? Consistency, that even is inconsistency in the timing of feeding. Again, making things as even keel, for keeping the rumen on an even keel as you can make it. Slug feeding. Tell you what, one of the times when I take a look at manure and I see a lot of grain in it, but the diet looks pretty okay, looking at the TMR in the feed bunk. But when I see how the animals feed, let's say there's restricted bunk space, or the cows aren't sure when their next meal is coming, and you get slug feeding and they eat as much as they possibly can at once, you get more material, you can get more material passing through. And if you see grain in the manure, that typically means it was not digested. Now, if you open up some of the husks on corn grain, the pericarp that's around it, okay, if it was popcorn, it would be the stuff that gets stuck in your teeth, okay? If you open that up and you still see starchy stuff in there, whether it came from high moisture corn or corn silage, that starchy looking stuff is material that didn't get fermented, okay? If it's finely ground stuff and it's still gritty and all, which is what I've more often seen with some of the slug feeding, that didn't get well digested either. You're not optimizing how well the rumen can work, okay? So avoiding slug feeding, which means giving adequate bunk space and reducing the amount of time the bunk is empty, can be your friend. Or, let's try this, can be the cow and the rumen's friend. And then sortability. You do know that cows have very few hobbies, right? I mean, they do check fence, they do check gates, they will poop in the milking parlor. They will also sort their feed. If you see a cow put their nose down in a feed bunk and go like this from side to side, and then go down further, she is letting the grain sift down to the bottom and eating that, okay? And Lou Armentano came up with an observation I thought was pretty good, that if a piece of fiber is longer than a cow's nose is wide, she can sort it, okay? What you want to do is walk around the front end of your cows and watch them while they're eating, because if they are sorting their feed because there's not enough moisture in the diet to hold it together, or you have really long pieces of fiber and they're either choosing not to eat or choosing to eat it, you might want to find a way to avoid that, because otherwise you have made every single cow in your herd their own independent nutritional consultant by letting them choose what they want to eat. Generally speaking, if you don't have pieces of forage longer than 1 to 2 inches long, maybe a little, down to 3/4, half, they're less likely to be able to sort in a moist diet. Okay, so all of these come together with trying to develop a ration that's appropriate for the cows and their healthy rumens. One of the approaches that researchers had taken was looking at physically effective fiber. And physically effective fiber basically gets at functional fiber. It's going to get the cows to ruminate, to produce the buffer in their saliva that's going to go back and help buffer the rumen to keep it from getting too acidic. It allows or affects that ruminal retention to hold feed in place and helps to maintain a desirable rumen pH. And forage, because of its size, its physical form, and its NDF contact through that entire particle, is going to have a greater impact than non-forage NDF. One of the challenges, I think, with looking at physically effective fiber is that I think it's a really good idea. It has investigated things and let us understand more about how the rumen works, but it seems to have had largely a research focus. Not exclusively, but more so. And there are ways to get the numbers to make this work. But again, my perspective, more of a research focus. And so the question is, can we come up with a system for looking at effective fiber that you can just make work on farm? Okay? Okay, before I get into how we might be able to do this, you know, I have a picture here of somebody trying to put together a 10,000 piece puzzle, okay? The other picture I was thinking of putting there was one of herding cats, okay? It could have been either one. But because when you're trying to come up with a system that people can use on farm and you're relying on research data as the most reliable information you've got, one of the issues is researchers do research studies for their own purposes, not for what we want to use them for, okay? So this researcher looked at grass, this researcher looked at alfalfa, this researcher looked at soy hulls, this researcher looked at sugars, this one looked at starch, this one looked at barley. How do you get all those pieces to come together into something you can rely on that you can bring to the farm? Okay. And so, I mean, because at the end of the day, the data that we find in the research studies, it's going to be as reliable as we can get, but it won't be complete or balanced for all the things we want to look for. It's just what it is. Okay, so the approach that we took was using an ensemble model. What the heck is an ensemble model, and why would I talk to you about this at World Dairy Expo? It's what they use for predicting the weather. An ensemble model, okay, if you look at what's happening in Oklahoma, in the Yukon, let's see, some parts of Kansas, maybe this is Wisconsin, this is over somewhere near Michigan or Ohio, let's say. They're going to have so many different things going on in each different area. They're each going to have strong suits for things that affect the weather that might inform the larger picture, but they only have it relative to where they're at, okay? But what they did is what they took was a core concept like predicting the weather and used a constellation of models that each had their own strong suit to be able to predict the whole. Hey! Thank you. Okay. Okay. So when we were taking a look, I don't think I've ever done that before. I'm thinking it won't happen again. Okay, so when we were taking the ensemble model approach for trying to do something with pH, and look, okay, and we used pH as something that all of the research studies that we looked at reported, but we used it as a proxy for the rumen being healthy, not as something we wanted to predict all by itself. We have our inputs, but then we ended up with models that could look at rations where we had a low starch expert model, a high starch expert model, a low forage expert, a high forage NDF expert, and low ADF to NDF or high ADF to NDF experts. And the ADF to NDF ratio speaks to how much grass was there versus alfalfa. Okay? So we could go beyond just focusing on one kind of forage, okay? What the ensemble model does is it takes the outputs from all of these and weights them and integrates them and comes up with that proxy pH that we were saying looks to be a healthy rumen. And then it came up with predictions for what did you need on an 8mm screen or 0.315, I think, inch screen of a Penn State particle separator to fall within the bounds for what looks like a healthy diet. Let me move, okay, and by the way, when you use a whole variety of different models as opposed to one big one that has holes in it, you could get some more reliable predictions. Never perfect, but perhaps more reliable for direction. Okay, so we came up with this physically adjusted NDF system. This is going to be reported in the next NRC, the nutrient requirements for dairy cattle, okay? We used a Penn State particle separator because that's what people are using on farm, more likely to than many other systems, though that does not exclude the systems that you send your samples out for. They may be telling you different things depending what system you take the numbers and use them in, okay? We looked at the factors that affected the need for or the effectiveness of fiber, because depending what diet you put them in, it changed. I'll show you that in a minute. We used a target ruminal pH of 6 to 6.1. It's a proxy for a desirable rumen environment, not a prediction. And we used 60 different publications with 241 treatment means to work in to develop this approach. The inputs are things you can get on your farm or from your nutritionist, okay? The diet characteristics as a percent of dry matter are forage NDF, total forage, and the percentage of wet forage in the TMR. Cottonseed, whether they be whole, hulls, or meal, mattered based on the experiments that we were able to tap into. You include NDF, ADF, crude protein, and starch composition of the diet. The animal's body weight. The Penn State particle separator values as a percent of TMR dry matter. What you need is that's on the 3/4 inch, on your 3/4 inch sieve, or 19 millimeter. And by the way, yeah, this is on the basis, a dry matter basis. We tried using it just as wet Penn State particle separator material, but there's too much variability in the amount of water that can be in each of those fractions. And so what you need to do is scoop the material, some of the material, off of your 19 millimeter sieve and run it through the microwave to get a dry matter, run it through a Koster tester or equivalent to get a dry matter, okay? And the output that this gives, after you put this in, is the recommended percent of the TMR dry matter that's on the 8 millimeter or 0.315 inch sieve. That was the output that seemed to give the best metric for what would get the ration in line for good rumen function, okay? We also have a prediction of minutes per day rumination, but I tell you what, don't look at that so much except as a relative thing of did it go up or did it go down relative to where you were starting if you're modifying the diet. I'm sure you can read this quite clearly. I show you this because what this system does is it will come up with a different answer for every single diet you've got. I mean, if you take a look, what we've got here, it's the percent of dry matter material on the 19 millimeter sieve at 6, 12, or 18% of the diet. This covers starch anywhere from 15% to 32.5% of the diet. This is forage NDF in the diet dry matter, anywhere from 10 to 30%. And this is the prediction of what percent of dry matter you would want on that 8 millimeter or 0.315 inch Penn State particle separator sieve. All different answers. And what you see here, and we'll look at this a little closer in a moment, this black line is the mean for what you're looking for. The gray gives you bounds above and below, min and max, for the range you might need to fall in to get what you want. Okay? Because you remember the list, and it's only a partial list, of the things outside of the ration that I told you were going to affect how the rumen was functioning? Far as I know, we do not have any system that takes those into account where you can just put in a number and say we're fine. What we always end up doing when we work with systems like this is we put together our ration and we still have to go walk the cows to see how they're responding. We will never get away from looking at the cows. I do not see how. Okay, so this is an example where we've got a low starch diet at 15% or a high starch diet at 32.5% of dry matter. And let's just take, for example, this, where we have 6% of the dry matter material on the 19 millimeter sieve. What you end up seeing as you increase the forage NDF in the ration, first we start out somewhere around 60% of the TMR dry matter needs to be on that 8 millimeter sieve, but as we finally hit somewhere around 17% forage NDF in the diet, we start dropping how much we need on that 8 millimeter sieve. And this is a function, as we get more forage NDF in the diet, the picture changes for what you need for particle size of whatever sort on this other sieve. Now when we get over to the high starch diet, and okay, let's just compare them down here at the 6% of the TMR dry matter on the 19 millimeter sieve. Compare what happened with the low starch diet to when we're dealing with a lot higher starch. You need that larger particle size. It can't be in the pan for a longer period of time as you're increasing the amount of forage NDF in the diet, okay? You need the larger particle size. You can't have it in the pan if you're going to try and maintain a better rumen pH, okay? So there are different responses that you've got to work with to be able to get within range of what we think is going to give you a more healthy diet for the rumen. Okay, with the lighting in here, this isn't showing up as well as I'd hoped, but I tell you what, okay, wait, let's go back. If you look at this, there is no way in God's green earth we can give you a table of all the possible answers that you need for real rations you're going to run into. So we have an app that's free. The app is called Munch. These are screen captures from my cell phone, and you can get this free of charge at Google Play and at the App Store. It's called Munch for Dairy Cows. And what it has is, here's the information on how much dry material you need on that 8 millimeter screen. Here's that relative rumination minutes per day I was telling you about. Don't use it as numeric. Look at high or low, how it changed. And here you have inputs for the 19 millimeter screen, diet ADF, NDF, protein, starch, body weight. And over here, your edit the forage and feed is where you have forage NDF, diet forage percentage, wet forage percentage, and the information related to cotton products. You can pull your phone out of your pocket and work with this on your farm. Okay. Now, the best information background that you can get on this, that you can grab and help you understand how to use this program, is through the University of Nebraska-Lincoln. And there is, under their Nebraska guide, there is an extension publication on Munch. And by the way, Paul Koninoff, professor at University of Nebraska-Lincoln, dairy scientist, was a point person on this. Dr. Robin White at Virginia Tech. This woman is brilliant, and she did the mathematical modeling and so forth with the ensemble models. And Jeff Firkins of The Ohio State University and I also worked together on it. So it was a collaborative effort across parts of the country, okay? But I mean, what that working with Munch takes you through is you put in your diets, it generates a recommended percentage of particle size, and you see, am I falling within range on this? And so if you have, Munch will suggest that you have minimal risk for low effective fiber. But if the answer is no, that's where you go back and you start modifying, well, what would happen if we got a higher percentage on the 8mm sieve? Or what if we change starch in the diet? And it will give you outputs that tell you, does it look like you're at greater risk or lesser risk for the rumen functioning well? And going back to this, full disclosure, this says you would want 41.7% of the TMR on the 8mm sieve for things to be working well in this case. Truth be told, this also tells you that's plus or minus 10 percentage units because it depends on how digestible the NDF is and other factors that we could not get data to enter into the program to assess. So it gives you a target, but it gives you a range, and you still need to go see what the cows think of what you've done. At the end of the day, what this program does is it integrates a whole variety of different factors that influence the need for and the effect of fiber in the rumen. And so with this lovely picture that Ginger Larson took down on the family's farm, I'd welcome any questions. Thank you. Bill.
I'm surprised to see just quantity of starch as opposed to rumen fermentability of starch.
Yep.
Or how long it was in fermented storage.
Which matters.
A lot.
Okay, if you go back, okay, forgive me. What the esteemed Dr. William Mahana raised, we've known each other a few years, and very correctly raised, is that this program doesn't take into account, let's say, how fermentable the starch is, which is going to vary by how long the material's been in the silo, by its moisture content, how finely ground it is. Did the processor actually process your corn silage properly? What else would you add to that list? That's pretty much it. This goes back to the picture where I showed the fellow with the puzzle putting it together. The studies that we could draw from did not report that information. And so we did not have the information to speak to it. I mean, the only thing I'd say in any sort of defense, and it's not really defense, is fiber and starch digestibility matter. And what we're going to need to do over time as we develop this further is see if we can gather the data that will tell us what the inflection points are, where things, as we change the digestibility and how much is fed, how will it affect what we're doing? But I think that gets encompassed under you still have to walk the cows and you still have to assess where pieces fit. Because, I mean, actually, and I'll give somebody else a chance for questions in a moment. I mean, if you take a look at that from a flip side, if you're feeding straw as opposed to incredibly delectable, soft alfalfa or grass silages that are going to digest a lot more readily than the straw will. The straw is going to stick around longer in the rumen to be effective as compared to the others. And you're going to have to treat them differently when you look at this. But we could not find the information to go after that. So, Bill, when you review papers, harass people to put that information in because it is crucial. And by the way, I will be here after this if you want to ask questions on the side as well. I will gladly do so.
Let's take one more question before we do invite folks to come by and stop and visit more. Is there another question from the audience here? Okay. Well, hearing none, let's give Mary Beth a round of applause for a really great presentation.
Thank you.
If you did not get a copy, if I didn't see you to give you a copy of the handout that is on the corner of the desk over there, I also want to highlight a couple business cards that you can pick up. One has a link for the YouTube videos that will be created from all of the seminars this week, and then also our webinar series. The center now